Good evening, everyone. Welcome to yet another episode of Promote Science. So, as you know, Promote Science is our humble initiative to spread science among the masses, especially school children. Today, we have a very special guest. We have with us Professor Sebastian from Indian Institute of Science, Bangalore. He is a J.C. Bose National Fellow in the Department of Inorganic and Physical Chemistry in IISc Bangalore, and he did his PhD way back in the 1970s in IISc, and he has won numerous accolades for his research work, to name a few, such as the Shanti Swarup Bhatnagar Prize in 1995, the Linus Pauling Lecture at the Mahatma Gandhi University in Kottayam in 1996, the M.S. Saha Memorial Lecture at the Indian Association for Cultivation of Science in 2005, and the J.C. Bose Fellowship in 2008. He is also a fellow of many national and international science academies, and editor of some reputed journals such as the Computational and Theoretical Nanosciences. So welcome, sir, to our interview. So, sir, the first question is how do you explain your research to a non-technical audience, say a 10th grade school student?
Well, that's a difficult one actually, because what I do is theoretical chemistry, and theoretical chemistry actually is the kind of theory that I do is a little bit difficult to explain, but I'll talk about one or two things that I have done which are not so difficult to explain. For example, one of the problems that I did was actually, if you have a long molecule, and I suppose they would know what a molecule is, and imagine it has to pass through a pore. Okay. So when first of all, the one end of the molecule has to find the pore, and it has to go to the other side. So therefore, this is essentially a problem where it has to go over something like a barrier. So the question one of the questions that I asked is, how does it do that? Now this is of great relevance, because you see, in biology you have long molecules like DNA or RNA and other molecules, and they usually, see, for example, if there are pores in the biological things like mitochondria, or there are things which are pores, and or even the nucleus of the cell has pore. So therefore, the question is, how does the long chain molecule go through this pore, right? And what is the dynamics? You can ask questions like, if suppose the molecule is made longer, what will happen to the time that the molecule will take to go through the pore, which is of great relevance in biology. So this is one of the things that I did. The another thing that I was interested in was the kind of work that won the Nobel Prize in Chemistry recently. This is essentially making nano-sized or molecular-sized motors. So this I was interested in around the year 2000. So you see, to have a motor actually means that it gets energy from somewhere, and using that it moves, or it rolls, or it does something. So that was actually very tough. So at that time, you see, this kind of research was not very popular. So I asked the following question: can I have a molecule which will sit on a surface? So you have a molecule, maybe it is sitting here, and when it is moving, moving essentially is the process of diffusion. So when it is moving, it will roll rather than slide. So I had such a design for a molecule. This was we did theoretical calculations, asking whether it will slide or whether it will roll, and the theoretical calculations showed that it rolls. And then we had worked on similar things. Now, the other kind of things that I do are actually, for example, the things that I did long ago. See, for example, you have a molecule. Imagine it is inside a cell, and this molecule has to enter the nucleus of the cell. So then what it does is, it actually will diffuse. It will move around, the molecule will move around, diffuse, and find the nucleus, and then only it can enter. Now, We know so much about the kind of motions that these molecules can execute in solution.
Yeah.
But inside a cell, the surroundings are very different. It is not a solution, but it is very crowded.
Yeah.
So therefore, one of the things, so this is something that I did recently, one of the things that I asked is, how does the fact that the inside the cell is such a crowded thing affect the diffusion? It makes the diffusion more difficult. So these are the kinds of things that I do, and there are other things that I do which are quite mathematical, and therefore it would be difficult for me to explain those things at a level that is understandable to a standard student, but I hope some of the things that I have already mentioned, they are interesting enough, I suppose. Even the mathematical things, I can say one thing. I have done some work on things which are called Levy flights. This is a term that will be very unfamiliar. But these Levy flights are actually, imagine you have a bird which is searching for a prey. It has to find the prey. And the way the bird actually searches for food, many times it follows a Levy flight. So this is the way, what is meant by Levy flight is, it will start from here, it will search in the neighborhood by taking small flights. And then you see, when it doesn't find anything, what it will do is it will take a big jump, big flight, land elsewhere and then search in the neighborhood. So therefore you have many small flights followed by a big flight. Like those kinds of things are called Levy flights. So I have done work on that kind of things too.
So, sir, like you talked about some molecules driven by some motors. So, can we compare them like, can we term them as like small nanorobots kind of thing?
Well, you see, the ones that I have worked on, they are not nanorobots, because you see, to be called a nanorobot, it has to be able to get energy from somewhere and move in one direction or do something that is useful. The ones that I worked on, this was, as I said, this was about 16, 17 years ago. They had no way in which they would take energy from the surroundings and do work. But now the Nobel Prize winners, they have actually developed the subject much more. And they have been able to synthesize nanomotors which can do work. But the motors that they have been able to make, they are still very, very inefficient. In our body, there are nanomotors which can take energy and do useful work very much, and they are very efficient.
Very interesting. So now, sir, going back into history, I would like to ask, like, how did you develop interest into research as a child?
Well, I have been interested in exploring things even as a 7th or 8th standard student. You see, I think that was the time when I was taught about lenses. Even before I was taught, you see, my brother had shown me a lens, and using a lens you can burn a piece of paper and so on. Those kind of things I used to do, and they were used for magnifying. And then the class, they taught us about a telescope. So I knew, I had already seen a lens. So I wanted to make one. In fact, I got money from my father and to travel some 32 kilometers on a bus. And then I had to go to a bigger town because lenses were not available in the town where I lived. So purchased lenses. And I still remember the shortest focal length that I could get was 5 centimeters. And the longest that they had available was 30. So therefore, if you make a telescope using that, you will get a magnification of 6. And then you have to be able to adjust the length, and so I made devices. It's not very difficult. I could make it so that you have to adjust the length, focusing on different distances. So I did that, and then of course there was a challenge to make the magnification higher. But I could never get a lens which was having a larger focal length. You see, unless you have a larger focal length, you will not have a magnification. So then I had this idea that I can combine a concave and a convex lens together. The only thing is that the concave should have a longer, that's correct. You should have a longer focal length. And then when you combine, you see the net result is actually a convex lens of having a larger. So that actually, that way I think I could make the objective about 100 centimeters and the eyepiece were 5 centimeters, so the magnification was 20. But then what happened was, you see, the lens radius was small. So because you see the light, the amount of light that comes in was very little. Therefore, even though the magnification was there, the clarity was not there. So that was a kind of disappointing thing. But then before I purchased these lenses actually, because you see I didn't know that lenses can be purchased and so on. So I would take a bulb, light bulb, break it, and then 2 pieces of them, you can put them together. And then I would put, what is the object?
Some sellotape.
No, there were no sellotapes in those days. Wax I would put, and then fill it with water, and they actually were nice lenses, but the thing is the water wouldn't stay there, right? Because you use candle wax to do this, and it will go away, it will break away in half an hour, and so these lenses could never be used for anything else. They were very clear, they were actually having a nice focal length and so on, but that was it. I used to do that kind of thing, and then later on, when I learned about surface tension, you can, for example, if you have a pin, right, you can float it on the surface of water. If you put it carefully, you can float it. I used to do that. And then I had the idea that I could magnetize it. And then if you put it on the surface of water, then you see it will point, it is a compass. And then again, when I learned of electricity, then I could put a wire on top of it and then cause it to be reflected. So I used to do this kind of thing as a student. I also grew some crystals, but I never had any chemicals. I mean, the only crystals that I had was of sodium chloride crystals I made. You take a small piece of a crystal, hang it on a piece of hair, and you have to get hair from a lady and then hang it, and then I could draw, I could make fairly decent crystals. Only of 2 things. One was sodium chloride, the other was copper sulfate. Because copper sulfate was easily available, because you see, I come from Kerala where we grow rubber. And copper sulfate is actually used for rubber. So I always was interested. I don't know why I was interested, but I was.
So it is like very inspiring to hear about your innovative things from your childhood. So sir, the next question is how can we make science communication more efficient for the general public, especially for school children? Like we heard your very wonderful talk in which you used several cartoons and many kind of small animations in order to communicate your ideas. So what is your suggestion regarding making this science communication?
Social media definitely. In fact, I teach the UG students in Division of Science. When the program, of course, it's not at the school level, but it is at a slightly higher level, it is immediately after +2. I was very enthusiastic about teaching them, and in fact, though when I started, I was actually worried whether because I had never taught at that level. I have always taught at the master's or higher level. So I said I will teach it for 1 year, and then it said normally I have to agree to teach for 3 years. I said no, I cannot agree to that. Because after 1 year I may not want to do it, because I don't know whether I will succeed. But that teaching was actually, I used all this kind of cartoons. So the students were very happy, and I also was very happy. So I have continued to teach. So the program has been in existence only for 6 years, and I have taught all the 6 batches. And in fact, I retired in July, but in August the course started, and they asked me whether I can continue to teach the same course, and I did that. But now I'm shifting to Palakkad, IIT. So the important thing is actually, this is something that I like actually, because if you have these cartoons, actually the students are extremely happy. And they don't sleep in the class.
Yeah, that is true. I think it was true for most of the students as well today.
They don't sleep, and each slide is actually each animation or whatever you see that keeps you awake, that keeps you anxious to see what is going to happen next.
Next year. Yeah.
And that is why I show them only one by one. I don't show everything at the same time. I have not taught at the school level, unfortunately, but I have been asked whether I can go and teach in the schools. I am going to take it up actually.
Thank you, sir. Yeah. So, sir, the next question we would like to ask you is like, how can we encourage more students, especially in rural India, and that too girls students, to take up research as a career in the long run?
No, see, the thing is, well, they have to be exposed to the excitement of learning. I mean, I would not necessarily they have to do science. They can do anything that they like. That's my policy actually.
Yes, sir.
So, but they have to be made aware that there are things which are possible. There are so many interesting things, right? I mean, see, for example, even painting. If somebody takes a painting, I mean, I would be happy with that.
Yeah.
So, whatever is your interest,
Yes.
it should be possible for a student from a rural area to do that. But unfortunately, you see, even as it stands, financial constraints are there. These things are changing actually. You see, when I grew up, it was just impossible to think of studying science because my father wanted me to become a doctor, medical doctor. Now, that is how the parents are usually, because that's where you are assured of a job and an income. But now things are changing. Now we are getting more affluent, and definitely India is getting more affluent, and therefore there is definitely a possibility to get jobs elsewhere, and to encourage students to take up any branch. You see, you have to expose them to that branch, whatever it is. Students have to know that
About the possibilities
about the possibilities that are existing. See, for example, in my own case, I grew up in a small town. It was not a village, but it was a small town. I heard of an MTech, and I heard of a degree like MTech when I was in BSc second year. I already was in BSc second year when I first heard of the degree called MTech. So therefore the awareness was not there. I mean, so I'm sure even in the rural villages, that is definitely the case. They are not aware of the possibilities. You see, they would not know that there is this institute called Indian Institute of Science. Who has heard about it? Very few people. So there has to be a way in which we can spread the awareness, and there has to be a way in which we can get them enthused. Maybe we should have some local clubs in the where, for example, like the activity that you are doing, if people can go there and show them
some demonstrations.
These days it is not difficult because we have electronic media. You can take a projector, and then we can take a computer, show animations, and things like that.
So actually we are planning to do some like these kind of demonstrations in like last week of January. So we have some ideas, like we go to some villages, and so we also have a 6-inch telescope with which we do regular sky watching.
That would be very nice. In fact, we make them to watch the stars.
Stars, yes. We will do. We are planning to start by like last week of January. So sir, the last question is like, what is your message to young students? Maybe students who are in 9th or 12th grade and who are about to decide on what career they can choose.
Yeah, well, you see, any career they choose, it has to be their choice. It shouldn't be their parents' choice. One. And you see, you have to do whatever you enjoy. If you enjoy science, then do science. If you are very good in painting, they should have the ability to go for that. I mean, you should have the freedom, not the ability. And they should be aware that, you see, if you are good in a field, it doesn't matter what it is. It may be archaeology, it may be science, it may be botany, whatever. If you are very passionate about it and if you do it well, you will definitely get a job.
Sure.
I mean, if you are second rate, then you will not get a job. But if you are very good, and to be very good, you have to be pursuing your passion. Otherwise, you will never be very good. So, you do whatever makes you happy. That would be what I would say.
Yeah. Thank you, sir, for your precious time. We had a very inspiring discussion with Professor Sebastian, and we would like to thank him for interacting with us and taking some time out from his busy schedule. Thank you, sir.
Okay, you're welcome. Thank you.